Okay, we have a few minutes for questions, and I urge the audience not to leave after the questions because we still have this promised surprise, 10 minutes more after the session of the questions for the declarations that I spoke about in the beginning. The speakers are invited to the stage. We have here microphones on two sides of the hall. And if you have any question, comment, complaint, anything, this is time to ask. Please go to the microphone and ask. And say your name, please.
Hey, my name is Ariel Weiss. I have one question for David Southwood and one for Harry Garber. The first for David Southwood, he said that when you built the Herschel Space Telescope, you needed for it to function at 0.1 Kelvin. And he said that if it won't be able to function at that low temperature, it won't be functionable. So I wanted to ask you, what was the specific thing about the functionality of that telescope that needed for it to function at such low temperature?
That's a very good question. The Big Bang, when it happened in a very, very small volume. It's been expanding for 14 billion years, and now, as it's expanded, the light from the Big Bang has gone down in temperature from billions of degrees to 2.7 Kelvin. And so, in order to measure that background light, which is out there across the sky, you have to make sure that your sensors are colder than it. Otherwise, they will measure themselves. And so it is simply to get below, and of course the more you can get below, the more sensitive you become to small changes in the radiation intensity across the sky. And it's those small irregularities, 1 part in 1 million, that really we see as the seeds of the non-uniformity of the universe we know. That out of a Big Bang, where everything is the same in all directions, things start forming into lumps, into galaxies, into stars, and into planets. So we're actually testing even the laws of physics, because we have to assume that physics was the same then as now, but fundamentally we have to get below the temperature of this background radiation. Originally discovered, just to show you, was discovered by people working for the telephone company in the United States who couldn't get rid of it. Well, I'm afraid you can't get rid of the universe. It's there. We live in it. And so actually sometimes fundamental astrophysical discoveries can be made by people doing just engineering problems associated with telecommunication. It's normally the other way. The advanced technologies come from the advanced science.
Thank you. And the second question for Mrs. Lori Garver, a bit of a funny question. You said that in the International Space Station they developed a vaccine for salmonella. So I wanted to ask what in the space station gave you the possibility to develop the vaccine better out in space than to do it here on Earth?
Oh, good. I'm so glad I don't have to answer the first question. And TJ could help me probably with this one. He actually sort of did. He talked about in the microgravity of space growing a perfect, he used the example of a cancer cell, but it's also the truth with human tissue. And so when we have human tissue in the microgravity of space, you can better test metabolites, drugs, vaccines. And that is what we've been doing in space. We even have a technology we developed in space, one of the astronauts, David Wolf, developed called the bioreactor that allows us to do this on the Earth as well. So that unique microgravity environment has really, really allowed a lot of these medical advances. Okay.
Thank you.
Thank you. Any more?
Hi. How often do you get to talk to an astronaut? That's cool. I'm 16, and I just started high school. And I wanted to ask you what the 3 things that you think it takes to become an astronaut, and where do I start now?
That's a wonderful question. There's a related question, and the related question is, how do you become an astronaut? And my honest answer is, I don't know. It's a moving window of opportunity. From year to year, when people make astronaut selections, you really don't know what the requirements are. Maybe next year we need all veterinarians because we're sending animals into space. I don't know. But there are 3 principles, and I smiled when you said 3, because there really are 3 principles that will serve you well through life and will help you along the road to becoming an astronaut. The first one is find the area of study that you love, that you have a passion for, and stay in school as long as you can and become really good at understanding that passion and to be able to contribute back in that same field. The second thing that I would say is learn to operate in a risk environment. I'm not saying be risky. I'm saying that everything that we do has risk associated with it, so learn to manage the risk and still work in that and be productive. For instance, hang gliding, parachuting, scuba, mountain climbing. Work in an area that has risk associated with it, but manage that risk. That's important because that's what we do. And third is be the best team player that you can possibly be. I am not saying be the best player on the team, but be the contributor on that team so that you yourself maximize what you can give to the team, to the progress, to the unit. You add all 3 of those things together, and it's a great series of tools for life progression, for learning more about life. And oh, by the way, when you do that, it strengthens you as a character and a person that makes you as a person even more astronaut contributory, and it helps you get in that field. If you don't get selected, you still have a very rich life by following those 3 things.
Yes, please. Take it at your hand.
You might have explained it, but I couldn't understand about the massive black holes. I just really can't understand how is the biggest of them are white. I mean, you can always see in the center of galaxies, you always show white, bright black holes.
I'm not sure that I see exactly what you're driving at, but are you asking about the location or why there are black holes in the first place?
No, why are the black holes white? You also always see in the middle of the galaxy, in the center, a big white black hole.
No, what you see in the center of a galaxy, you see the radiation that comes from the vicinity, from the surrounding of the black hole. There is an awful lot of radiation produced there, but you cannot see the black hole. You can only see the radiation that is emitted by material that is going into the black hole, on its way to the black hole. So you look at galaxies and you see a very big amount of radiation coming from the center. Sometime, and this is the funniest thing in a way, when we see a lot of radiation, we conclude that there is an object there, a black body, that produces no radiation. It looks like a conflict, but the only object that can produce so much radiation in a very small volume must be a black hole. So we don't see the black hole, we infer the existence of a black hole because we see so much radiation from the center of the galaxy.
Thank you. Hi. This is for for Ms. Garver. Earlier, before you said something about, something with, something with health stuff in space. I didn't really understand that. Could you explain it again? I don't know. You said you could cure stuff in space and couldn't cure it here in Earth. I don't know.
No, don't move the microphone when you speak. We don't hear you.
No.
Okay. Earlier you said that you were doing some medical stuff in space. Could you please stop laughing? Okay. You said you were doing medical stuff in space. Does that mean you're trying to find cure for AIDS or something?
So I think it's similar to the earlier question about what we're able to do in microgravity with health in space. We actually are looking at the health of our astronauts, since until we can really learn to operate in space over long periods of time, we are not going to be able to take those longer missions out past the moon, to the asteroids, and to Mars. So doing studies on the effects of microgravity on our human bodies are something that the astronauts are doing actively in space station all the time. But in addition, we use the microgravity environment of space to do biomedical research to help us here on Earth. You talked about cancer cells and so forth. Is that what you're talking about?
Wait, but what can you do in space that you can't do here? What kind of tests can you do in space and not here on Earth? Why do you need the whole...
Perhaps it's better not to ask what can we do in space that we can't do on Earth. Let's ask a slightly different question that helps this, I think. When we go to space, we remove gravity and the gravitational effects on our bodies. That is very important because we can then take a look at things that we see on Earth over a longer period of time than we do on orbit. For instance, I was up on orbit for 5.5 months. In those 5.5 months, I lost a good percentage of my bone density. That's very predictable now. We're beginning to understand that process. And guess what? That process looks like what happens on Earth to aging populations for osteoporosis. And now as we take a look at that problem, we're able to address it through our medical concerns for longer travel in space and the countermeasures we're using on orbit now in order to compensate for an osteoporotic condition, which affects everybody.
So you're saying you age less when you're in space?
Well, taking into account Einstein's relativity, I aged less. That's true, but only by microseconds. But we actually have an aging effect that we biologically suffer from on orbit. And one of the things we do on orbit a lot is an awful lot of exercise, 2.5 hours a day, in order to combat muscle decay, bone loss. And so to answer your question, yeah, we actually look like we aged a little bit on orbit. And we're using that as an opportunity to study longer-term effects.
Thank you. If you may, let the other.
Hello. Colonel Timothy, how did you feel the first time you went to space, and how did it affect your view about God?
How did I feel when I went to space, and how did it affect my view of
God?
Okay. Well, that's an important distinction. The first thing I'll tell you is I've been in the Army for 30 years. We're coming up on 30 years. And as my first answer to how I feel going to space was, it was another flight that I had to pay attention to in order to launch and get to the space station. That's what I've been doing my life. I've been an active aeronautical aviator. The actual sensation was a very smooth acceleration up to about 3 Gs. And then once you hit orbit, it was a wonderful relief of relaxation because I've been sitting in that seat for 3 hours and I needed to get out. So those are the sensations. In terms of affecting my view on life and God and humanity in a sense, it deepened the value. You look out the window and you are awestruck with humility to the point where, let me give you an example. I have brought crew members who had never been in the cupola. You saw the 7-window, who had never been in cupola before. I brought them in to a cupola, had them close their eyes because the windows were closed. I opened up the shutters so you could look out the windows, and then I asked the crew member to open their eyes, and I watched them cry. It is that beautiful.
Thank you.
Yes, please.
I kind of have two questions. The first one is that a couple of years ago, I heard an astronaut talks that like from 2010 to 2015, they're going to shut down shuttlecraft and start building some sort of new kind of space vehicles for human exploration in space called the Constellation. Is that like real?
Well, there's been a lot of developments in human spaceflight, and it seems like you're referring initially to the space station, that there had been a plan to deorbit in 2015. We've actually decided not to do that. This is an unbelievable international laboratory. You got to experience it personally here with the videos that we saw, and the amount of science that we're talking about, as well as these really, really important international partnerships on space station, we intend to continue. So the United States, who has funded the majority of the space station, decided we would extend and pay for it at least until 2020, as we talked about, and our international partners are all going through their agreements now and have all agreed, and hopefully budgets will follow to do the same. We had been planning to follow up the space station with a program called Constellation, using a larger rocket, again, from the United States, with a crew capsule that would go back to the moon. And we are looking now at developing deep space missions like that in the United States to go to a variety of destinations. But the President has said we will go to an asteroid next by 2025. What we're really trying to do with NASA, and hoping to work with our international partners, is utilize the International Space Station to learn to live and work in space, and to then push the boundaries farther, to go to all those very exciting destinations for science that the panel talked about, and for that human spirit that TJ just talked about.
Yeah, going back to the part about the moon, that was actually my second question. What are the future plans about going back to the moon? I mean, we kind of left it in the 70s. What are we going to do now?
Going back to the moon is something, I mean, the U.S. has landed on the moon, and 12 American citizens have walked on the moon, which is a very, very exciting thing. And I have no doubt that humans will be back on the moon hopefully very soon. I would like to see that next time we go be an international mission. And I'd like to see some women along for the ride. That's my first.
Hey, can I ask one more thing?
Excuse me?
Can I ask one more thing? I kind of thought of another question. What about commercial space flight? That I'm hearing they're starting to make plans for that. Do you know anything about that?
Yes, absolutely. When we are looking to, as I mentioned, build the deep space rockets, we are working with our private sector to develop the commercial space transportation to and from the space station. We're doing it first with cargo. We had a successful launch of one of the demonstrators of that technology December. And we're looking for more of those this year. We hope to follow that up with transportation of our precious crew to and from the space station, so that we can invest a larger and larger share of the NASA dollars in those exciting missions beyond.
Okay, thanks.
Since I see the long queue for asking questions, what I'm suggesting, you ask your questions and you write it down, please. And then we will let each one of you answer all the relevant questions, okay? So one by one, please ask your questions.
Okay, good evening to everybody. My question is for Colonel Timothy. You know, almost every kid's dream to be an astronaut and do the moonwalk on an actual moon. So I wanted to ask you if your dream was to become an astronaut, or whether your dream was something else and you happen to be an astronaut.
Thank you. Next one, please.
Hey, my question is for Professor Netzer. You said that black holes, when they get near each other, they get closer and closer until they combine. Do you believe that 13 billion years ago there could have been a numerous amounts of black holes which combined, accumulating something as big as the Big Bang could be? That's my only question.
Hi, my question is to Colin Timothy. Can you explain us a little bit about your journey to the space? Just about your journey. How's the journey and all the physics?
Did you understand? No.
Thank you.
Hello. My question is to Lori and maybe Colonel. What's your name? I wanted to ask about the colonies. If you're planning to build colonies on Mars, and how will they be? And what's the progress on the colonies? Thank you.
My question's for the astronaut. I can't read your name from here. Sorry. But I was just.
I'm just teaching. My mother used to say Timothy John when she was angry at me. So just real easily, TJ.
Okay, so for TJ. I was just wondering if you kept in contact with any of the people that you've been on the space station with.
Okay, my question is also for Colonel Timothy. I was just wondering, why is it like to live for such a long time in zero gravity?
Hello. My question is about the galaxies. There's a theory that our universe expands by time. And I don't understand if the universe expands, how then the galaxies, they move from each other and not to each other. So how can they collide? Thanks.
Okay, last question.
Hi, my name's Dana, and I have a question for the Colonel as well. Did you ever thought about it that you may not come home? Were you scared? Because I think it's pretty dangerous. I don't know. Thank you.
Please, perhaps we shall start by you, Lori.
All right, I'll answer how great it was to work in space and how much I have kept in touch with my International Space Station partners. I wish that I could answer that question. But I get a great question. What do I think about colonies on Mars? How can you not think anything but wonderful things about colonies on Mars? I grew up in the 60s, and while I certainly thought I would get to walk on the moon in my lifetime, I think that Mars has always been that goal, and I still hope to see it in my lifetime. NASA has a unique role to explore. And as we do this, we are an exploring species. So Mars is a natural place that calls us. The question of colonizing Mars, however, is probably not a NASA endeavor. We do that first thing. And as explorers, when we go, we are hoping to go in a way that further generations can continue to go in a way that will allow us to colonize the red planet. We always, always want to keep in mind this precious, precious blue dot that we call home. But how wonderful when it is not humanity's only home. Thanks a lot.
If I can dovetail, there is so much rich history in science fiction that really began birthing in the mid-1800s when people knew the physics of what had to happen in order to go exploring in space. And one of those things, of course, is colonizing Mars, which leads me to set up a couple of questions. Did you realize that every species on Earth that has ever gone extinct never tried to leave the planet? So let's try to leave the planet. And then as I think about that, just out of curiosity, by a show of hands, how many people think that we will forever, all time, always, eternity, only be on planet Earth? A couple people. How many people think that we will eventually get off Earth and go someplace else? Good. We have to start now. It takes so long. The ship that we have built is very safe when it stays in the harbor, but that's not why ships have been built. So let's go off and explore, and that leads us to colonizing. Okay? All right. Since I got the microphone, somebody asked about my dream. You know, it was actually almost an accident, but all through school, my science and my math teachers encouraged me in science and math all through school, and that was one little spark. I'm old enough to have seen Neil Armstrong walk on the moon. That's another little spark. I get into the Army. I fly helicopters. That's another little spark. And then when you're about 5 years old in the Army goes, what else do you want to do? We know you're an aviator. What's the second? I said research and development. And because of that, they sent me a free magazine called Research and Development and Acquisition. And the first article I read in that magazine was the back cover that said, typical profile of an Army astronaut. And all those little sparks went into a big flame, and that's how it started. But I was seriously older than a kid, for sure. The journey. I forget what the question was about journey. Let me skip that. Contact with ISS. Yes, I've maintained contact both by phone calls as well as by email with the folks who've been on orbit. A lot of the stuff I did up there with my experience, people are asking me how to do things, where are things, that kind of thing, and also to simply share with the joy of what's going on at the space station. Did I ever worry about coming home? Not in the sense that I think you asked the question. It was a very rewarding professional time. We were very conscious of the risks that we were taking and how to manage them, which is why I mentioned one of my 3 big points is continue to work in an area where you can manage the risks that you have to do. And I maintain contact with family and friends almost on a daily basis. Perhaps you know that you can make internet calls via computer, and that's basically what we do when we call home. We use the internet to call home. And does anybody use Twitter? Okay, there was this crazy guy, crazy astronaut who hooked up and tweeted from space, and who will ever since then be known for 140 characters where I had a misspelling. I took a couple of notes. I'll come back and I'll pass the mic at this time.
Thank you. David, would you like to add something?
Yes, well, actually, I think I'd like to comment on the colonizing first, because I know we love the Earth, but do you think really this is the best we can do? And moreover, I know we're all very clever, but do you really think that this is as far as sentient beings can go? I don't know. I'm a great reader of science fiction. I'm, in fact, patron of the British Science Fiction Foundation. And I regard that as part of my job as a scientist. Of course, some of it is just fantasy. I don't actually like that. I like the bit that stretches your imagination. I have to say, when this planet was populated by apes or dolphins as the highest order of intelligence, maybe they had no conception that people as smart as you would come. But frankly, humans evolve. We're changing. Even, in fact, you mentioned Twitter. The fact that we now have with us machines that change the nature of how we communicate. We have mobile telephones. We have texting. Really, this is changing us. We've got to try and make sure it changes us so we survive as a race. But ultimately, there's something that physics tells you. In 1 billion years' time, this planet will end. I can tell you how it will end. The sun will become a red giant. I somehow feel that we can't just be the beginning and the end. Maybe we are, but I think it's probably better to assume we're not. And in those circumstances, you have to be thinking about what's over the next horizon, even if it is a very long way away. I'm perfectly serious about it. I'm a scientist. I have no embarrassment about saying this, but I think really we live in an age when it's so. Now, I have another question to answer, which I at least take it, maybe we'll share it with Professor Netzer, about the issue of the expansion of the universe, and also about black holes And then you may have heard also of dark energy and dark matter. We call things black that we can't see, but we think we know. And I actually believe of those three things, the thing I'm surest about are the black holes, precisely because we have a very clear understanding of our physics, and only a black hole could make the radiation we see. Even more puzzling, though, is the fact that the universe is expanding, and not only that, it doesn't appear to have expanded uniformly. You can go back and say, oh, we got it wrong. Einstein got it wrong, because really we're at the moment still showing Einstein was right. But I think also you have to understand, when we talk, even more threatening perhaps is the fact that when we look at the heavens, we think we're looking at the universe. But actually we're seeing about the light we see coming from the stars, from the galaxies, from the nebulae, from the planets, reflected from the planets, but it's still light. That represents only around 4% of the mass we know to be out there. Now, we know it's out there because of its gravitational effects. The frustrating thing is, if it was mass as we know it, using the words of Captain Spock, it's not mass as we know it, because it isn't emitting light and so on that allows us to determine it. So we know there are vast amount, the majority of the universe, of the galaxy we live in fact, Gaia, the program I mentioned, for me, its primary target is to map what we can't see in our galaxy, as well as to follow the things we can see. It's to map the dark matter. The hidden matter might be a better word. Anyhow, when you look at it this way, perhaps I overemphasized how much we do know. We do know an awful lot. I don't want to criticize anything Albert Einstein said about the universe, or then was followed up by astronomers in the succeeding century. But there are big mysteries out there. The expansion, I don't doubt at all. The manner in which it is expanding is, for me, a major puzzle. How do I think of the expansion? Well, it did change the universe for me. You may have detected when I was young, I had a certain difficulty, perhaps not as religious as my mother would have liked, and she firmly, back in the 1950s, she loved astronomy, and she was a firm supporter of the idea there was a Big Bang. And I was a firm supporter of the idea that the universe was, is, and always will be exactly the same, a steady state universe. I was wrong. My mother never stopped crowing about it. She thought it was good to see me get things wrong, and that was good for me too. But it's a fact. There are innumerable facts that we've deduced as scientists from what we've seen from space and also from the ground. The universe is expanding. It is, the scale of the universe is endlessly expanding. I think it's going to expand forever, but it means it had a beginning. It probably means it doesn't have an end. But that doesn't let us off the hook as a race, because our planet, where we live so comfortably, I assure you, it's in the stars, or it's in our local star. It's going to end. And you can think, maybe then is the time to go and live on Titan, because it has an atmosphere, it has everything the early Earth had. I don't know. But whatever it is, I think we need to keep thinking about this and also trying to improve things down here.
Thank you.
Is there another question I should
Okay, I'll be very brief. I'm going to apologize for the person who asked about the black hole, because I sense that this person knows the detail of black holes and such, and any answer to him will require more time than I have here. So maybe I'll skip that. And I just mentioned one other thing about the expansion of the universe that Professor Southworth explained so well. We physicists try to learn about things, and when we don't know the answer to something, we invent a phrase, okay? So lately we've been very good in finding things, but also in inventing phrases. And one of them is the cause of the expansion of the universe, of the accelerating expansion of the universe. And this phrase, this coin, we call dark energy. And whenever I speak about it, I say to the audience, and I'll say to this audience, that it only takes 6 words to explain exactly what dark energy is. We don't have the slightest idea.
Okay, I will make it very short. Since most of my career was in the military and in the defense, I do believe deep in my heart that not 1 billion years, but between 50 and 100 years, the human race will extinct itself. Sorry.
Okay, I would like to thank the panel, and I think it was quite an interesting.